Okay, we're on to problem number 35. So what do we have? It says, in exercise 35 and 36, two samples are given. In each case, find both the sample standard deviation, find both sample coefficients of variation, decide which sample has the higher dispersion and which has a higher relative dispersion. So to do the dispersion, we're going to compare the standard deviations and compare relative dispersion. Let's look at the coefficient of variation. So we have 5 data points. So we're going to need a table that's this size. So first case is 3, 7, 4, 3, 8. So we need the mean. Let's add these numbers together. 3 plus 7 is 10. 10 plus 4 is 14. 14 plus 3 is 17. 17 plus 8 is 25. And we divide 25 by 5. We get the mean is 5. We have data. We have what's it called? It's called the deviation. So this number here is 2 less than 5. This one's 2 more than 5. This one's 1 less than 5. 2 less than 5, and 3 more than 5. All I'm doing is taking this number, subtracting that number. Add those numbers together, should get 0. And then should be, that's a V, not derivation. But then we have deviation squared. So we just square these numbers. 2 times 2 is 4. 2 squared is 4. 2 squared is 4. 1 squared is 1. 2 squared is 4. 3 squared is 9. Okay, so you add those together. 4 plus 4 is 8, plus 1 is 9. 9 plus 4 is 13. 13 plus 9 is 22. So the sum of the squares of the deviations is 22. So our sample standard deviation is the square root of 22 divided by 5, which is the number of data points, not the mean, but the number of data points, minus 1. And let me get my calculator. So we get square root of 22 divided by 4, and I get 2.35. And the coefficient of variation is the standard deviation divided by the mean times 100. And I get 46.9, which is pretty big. So the standard deviation is 49% of the mean. Okay. The next one we have 7 data points. So I'm going to need 9 rows. So I'm going to make a 5 by 5, and then I'm going to duplicate that. And we have the same columns. So our numbers are 10, 8, 10, 6, 7, 3, 5. We don't need this last row. So we're going to add those together. So 10 plus 8 is 18, plus 10 is 28, 28 plus 6 is 34. This is 10, so it's 44. 49 divided by the total number of data points, which is 7. So the mean is 7. X bar equals 7. So these numbers add together 49. They're making it easy on us, giving us a whole number. So now we're going to subtract 7 from each one of these. So you'll get 3, 1, 3, -1, 0, -4, and -2. And again, if you add these up, 3 plus 1 is 4, 4 plus 3 is 7, minus 1 is 6, minus 6 more is 0, so that's good. And then we square these numbers, so 3 squared is 9, 1 squared is 1, 3 squared is 9, -1 squared is 1, 0 squared is 0, 4 squared is 16, 2 squared is 4, and now we add these together, 9, 10, 19, 20, 36, 40. So the summation of this is 40. So our standard deviation is the square root of 40 divided by 7 minus 1, or 40 divided by 6. So we take the square root of 40 divided by 6, and we get 2.58. So the standard deviations are pretty close to each other. This one is lower, so we would say that this has the highest, this would have the highest dispersion because of this, we're comparing standard deviations. But if you look at the coefficient of variation, actually that's not 49, it's 7. 7, so we do that, multiplied by 100. .58 divided by 7, and I get 36.9%. So from a relative dispersion standpoint, this number is lower than that. So this has the lowest relative dispersion. This has the highest dispersion. Relative dispersion, use the coefficient of variation. Just the dispersion, use standard deviation. Okay, the last one is 38 through 40. So we've got a bunch of tires that we have. I think that's what it is. Tires, modules, some kind of module, not tires, and they last a certain time. It says the modules can be fairly consistent in their lifetime, so the preventative race placements can be timed efficiently. So they're saying that because the length of time that they are failing is such a small, it's a very narrow window that you can schedule that kind of thing. You would schedule the maintenance before most of them, or not all of them, failed, and then you won't have any failures, and it could be expensive. So anyway, the 3 questions they're asking are which brand of module has the longer average life, and that would be using the averages. It says which brand of module apparently has a more consistent or uniform length of life. So in that case, you would use the standard deviation. And it says if you have the 2 brands, which one would Chris purchase for the maintenance program, and explain reasoning. So there could be more than one answer if you can explain it well. So let's see what it says. It says he tested 20. This is brand A. He said we tested 20 modules, and they lasted. We'll say the life is X. Lasted 48,560 miles. So that's the mean, with a standard deviation equal to 2,116 miles. So that's our standard deviation. They're giving us that information. Then we're getting the B information here, and we're asked to calculate the same properties for brand B. So we're going to have to do that by manual, and then we'll compare the two. So they're just trying to save you having to do this thing twice by giving you the data for one of them. And there are 5 times 5, 25 data points. So this is going to take 25, 27 rows. So I'm going to make one that's 28. And it's going to be fairly long, so might not be able to get it all on one screen. We'll just have to scroll down. This is something that doing on your computer would be easier, but I'm going to stay away from that until you do your project. Okay, so there's your tables, and so this is the data, which is the miles. This is the deviation. This is the deviation squared. So let's just go ahead and list all this stuff. So it's going to take quite a while to put all this together. And again, we don't need to worry about the putting them in numerical order. And the longer I do this, the more I'm tempted to use the computer. So we're going to do that. So I'm going to switch over to Google Docs. And I'll share it with you here in just a second. So once you get into Google Sheets, so remember what you do is you go to Gmail and you click on this thing up here in the right hand corner. You go to Sheets. Okay. Once you do that, you'll get to this point. So you're going to create a blank worksheet, and we're going to create the table. And remember, you can pause this, so I'm not going to slow down. You can just stop it when you need to pause. So we're going to have the data. Let me move my pad out of the way here. Okay, so that's the data. This is the deviation. This is the deviation squared. And now we're going to enter the data. So, again, you can do this slower if you're not as quick as I am. So just start entering data and push enter. And so what I'm going to do is I'm going to pause right now, and I'm going to enter all the data, and you can enter all the data for this column. So let me start recording. Okay, there actually are only 20 data points, not 25. So anyway, so you can see the data. I've put it all in column 1. So the first thing we need to do is to figure out what the mean is. So I'm going to write mean here, and then we'll put it in the cell right below. So the mean is equal to, well, we'll use the formula, average, left parenthesis. Then we'll take our cursor, stick it in this cell, and we'll drag it all the way till we get to the first data item. So it should say average, left parenthesis, A2 colon A21. Push enter. So that is the mean, which compares with 48,560. So this has a little bit higher mean than brand A. Okay. Then you calculate the deviation. So the deviation is equal to the value, the data value. So I click here in cell A2, and then I divide by the mean, which is down here, cell A23. But I have to push F4 to get those dollar signs to make it work out right. So if you move your cursor up, the deviation, oh, that's because that's not deviation, it's subtraction. I divided by. I don't know why I did that. Okay, so it's the subtraction. So the deviation is negative 4,193. This number is that number less than the mean. Now once you've entered the equation once, you can grab the corner and you can just drag this thing down to get to the bottom, and you just let go. And so those are all my deviations. If I add the deviations up, I should get 0. Okay, the deviation squared, you'll say equals, and you'll say deviation, click on this cell B2, little hat, which is shift 6, and 2, so that's squared. So you get the big number, and the formula has been entered, and so now I can just copy it down. So go to the corner, grab that little box, drag it down while I'm holding the mouse, and let go. So those are all my deviations. They're all positive and a deviation squared. So what I have in this, I'm going to say sum of deviations squared. So I'm going to add, or sum. So it's equals sum, left parenthesis. I'm going to click in cell C21. I'm going to hold the mouse down, drag it up, highlight the whole thing, put a right parenthesis, and then enter. So my sum of the deviation squared is this big number. Then I can calculate the standard deviation. And we're going to put that in this cell. So the standard deviation is equal to square root of this number, the sum of the squares, divided by the number of data points. Well, there are data points minus 1. So there are 20 data points minus 1. Close the right parenthesis, another right parenthesis to match everything up, and I push the enter button, and the standard deviation is 3,542. So I'm going to take those numbers and I'm going to enter them in my small report, and then I'll switch screens. So 48. So for B, I have that the mean is 48. Again, I'm writing this down. I'll show you in a second. 48,793. And the standard deviation is 3,542. 3,542 miles. Okay, let me share that back with you now. Okay, so there are your numbers. And so the question 38 says, which has the longer average life? So 38, the answer is brand B has the higher average. The second question is 39 asks the question, which brand of module apparently has a more consistent or uniform length of life? Well, the consistency is related to the standard deviation. So brand A has the more consistent life, because that's the smaller standard deviation. Now, the question is, which is more important? Because the average lives are only about 200 and some difference, whereas the standard deviations are much larger. So if I took brand A and I took the mean minus 1 times the standard deviation, I'd have 48,560 minus 2116. and I get 46,444 miles. So if that's brand A. Brand B, if I take this mean minus 1 standard deviation, I'll get 48,793 minus 3,542. And I get 45,251. So even though this has a lower average life, if you take into account the variation, the one that has a higher life but the larger standard deviation, looks like it may be not as good an idea. So I would choose brand A, because the whole idea is schedule maintenance, and if you if you get most of them right, that's fine. But if you get one wrong, it could be very expensive in terms of cost. And 48,793. So the book, it says 48,796. So I don't know if I typoed in a wrong answer or just mine's more accurate. I'm not sure. Okay, so that's that.